Okay, so let us start matrices, what we call a matrix in singular. So we have a matrix with, let's say, m rows and n columns, and the entries of matrix are going to be this one: a11, a12 up to a1n, and a21, a22 up to a2n, and a. So these are going to be rows. So am1, am2 up to amn. So this is going to be our matrix, what we call some sort of rectangular arrangement of entries or quantities or variables or whatever you will say. And in compact form, sometimes we write that it is collection of some sort of entries. Let us say aij, where I are rows, and rows run between 1 and how many rows? M rows, and j runs between 1 and n. And then there are lots of types of matrices. Okay, what do we mean by a row matrix in which there is only one row, a column matrix in which there is only one column, and square matrices, diagonal matrices, scalar matrices, and so on. But we are not going to discuss each and everything in detail. Okay, so this is what we call a matrix in which there are how many rows? M, and how many columns? N. Are we okay with these rows and columns, or there is some sort of another idea? I think the first number is called a row and the second number is called a column. Okay. So what if we have M is same in N? It means we have a matrix with n rows and n columns. We call it square matrix. So this is the notation of a matrix. Whenever I write M or any capital letter with some sort of subscript like m cross n, it means I mean a matrix with m rows and n columns. And this is a matrix with n rows and n columns. Sometimes in short I will write this Mn. Means it is a square matrix with n rows and n columns. And what is the order of a matrix? We know very well this is R cross C. How many rows are there and how many columns are there. So the order of like this matrix is going to be n cross n. Okay. So there are fundamental types of matrices. Fundamental types, not the advanced like what is orthogonal and what is unitary. We'll be discussing these things later on. Right now, what we are going to discuss, how to add vectors, how to subtract. We know very well if the order of the matrices are same, we can add the matrices and we can subtract as well. How about multiplication? How can we define multiplication, and when can we find the multiplication of two matrices? So, let us say multiplication of, let's say, matrices M by N. This order can be anything, but I am writing M by N now. So I have a matrix A, I have a matrix B. So let us say the order of A matrix is, the order of this one is, so let me write it here, and this one is, let's say, n times P. So how many rows? N, columns N, rows N, columns P. So the columns of first matrix is same as the rows of second matrix. So how can I find out the multiplication of these two matrices? So simply we know very well row multiplied by column and so on. Now what am I going to do? I am taking my matrix AB. What is matrix AB? It's the product of these two. And I am going to define some sort of ijth entry of this one. It means I am going to define a particular entry. And how to get that entry? By definition it is ai1 b1j plus ai2 and b2j up to ain and bnj. Do you get this particular idea? You know very well, this is a matrix AB. It will be a matrix. I have a matrix A, I have a matrix B. What is the order of A? M cross N. B, let's say N by P. So what is the order of AB?
N by P.
That is
by P.
NP. It means how many rows? M. How many columns? P. And I am defining a fixed entry in this one. That I have so many entries. Let us say these. How can I find out a particular entry? So to find out this particular entry, the answer is this one. For example, what is this entry? A11. How can I find this entry A11? What do you do? Just replace here I with 1 and J with 1. That's all. So what happens if I replace I with 1 and J with 1? It means I am interested in this one. The 1 entry of AB. So what this becomes? A11 B11 plus A12 B21 up to A1 and B and 1. So this is your first entry of your product matrix AB. And now let me tell you what happens basically. When you say you multiply a row with column, this is exactly what happens. What is this? A11, A12 up to A1n. This is the first row of your matrix A. You are multiplying it with the first column of matrix P. What is the first column? B11, B21 up to B. This is how you find any particular entry in your product matrix. So this is a definition. I rather discussed something that in some sort of rigorous way, otherwise we can only do how to multiply these matrices. But sometimes when these things are asked, we should be clear that when we define multiplication, basically we define what do we mean by some fixed entry in our product matrix, and this is defined in this way. And this is, I gave you an example that what happens basically. So we are not going in this detail. We know very well how to multiply matrices.
Sir, in multiplication you are not defining the orders. Here N, P.
Which one?
Here. The definition.
This is a matrix.
Right.
But I am going to define only one entry of this. This is not a product. This is one entry. And you know very well one entry is some sort of multiplication in sum like this. You take a row, multiply with column, and you exactly get this thing. This is what happens. Okay, what happens when you multiply a matrix by null matrix and identity matrix? We know very well. You multiply a matrix with identity matrix, you get the same matrix. You multiply a matrix with, let's say, a null matrix, you always get a null matrix. What is the transpose of a matrix? So you have a matrix M, which is, let's say, M by N. So you are going to transpose it, you get a matrix which is N by M, and this is exactly how we define the transpose of a matrix. And entry wise, if there is some entry in this one which is Aij, in this one that entry becomes Aji. So entry wise there is a difference in this way. For example, very basic example is A11, A12, A21, A22. This is, let's say, a matrix A, and I am going to find out its transpose. What happens basically, that you have an entry with A11, you are going to replace these two things. Then what happens? You exactly get same thing A11, hence it is placed at the same position. When you replace these two things,
Diagonal in the same.
diagonals remain same. When you replace these two things, it becomes A21. A21, it means you will take this entry and you will place at this position.
Yes.
Take this entry and place at that position. And when you extend these two, it becomes 1, 2. It means you take this entry and you place this entry at this position. The entries itself remain same. Just you change their positions. It means the entry at Aij position is replaced with the entry with Aji position.
But this method is possible in 2 by 2 only.
Always.
3 and 3.
Always. 3 by 3, 4 by 4. Always it is possible. You just exchange the entries.
Well, the diagonals, we know that diagonals remain same, either 3 n by n matrix, any matrix. They remain on the same position.
Yes.
But 3 by 3.
You take any matrix. For example, we are taking this matrix. A11, A12, A13. Now what is the transpose? You take this entry, it remains at the same position. This is 1, 2. You have to write at 2, 1 position.
So I am saying 3 by 3 matrix. Fine.
Any matrix. Any matrix.
1, 3 के वही है
A11, A12, A13, A21, A22, A23, A31, A32, and diagonals remain same, you know very well. What happens now? This entry is replaced with this one.
So you both है ना यानी मार जो फिक्स करे है ना क्या और मार वो तो सोचा था जब 1 2 जो के रखा हूँ पति 1 3 की फिक्स करे तो ये है नहीं.
This is 1, 3. You extend these, this becomes 3, 1. It means it will take this position and this will take this position. So there is a reflection along the diagonal. So this is principal diagonal and you basically reflect the entries. Like this one goes here and this one goes here and these entries remain same. This is what we call the transpose of a matrix. And the ordinary things we know very well. But there are some non-trivial things that we should discuss about any new idea that we are going to do. Like there are some trivial things I will not be discussing ahead, but I am going to tell you right now. You do this thing, you get some matrix here. And you take transpose of A plus B, you get same thing as A transpose plus B transpose. But the non-trivial thing is, what is this?
reverse.
It is going to be B transpose, A transpose. So this is something that we should keep in our mind. Otherwise all the things are going to be very trivial about this transpose. Okay, so the next idea is, and we can also define what do we mean by the power of a matrix. So if I want to give some power of a matrix, let's say A power k, what do I mean by that? A power 2, A power 3, A power 4, and so on.
Times k
Times. It means if this k is a natural number, that's not a problem. Then what can I do? I can multiply A with itself. How many times? This is exactly k times. Later on we will see that how can we do this thing. The square root of a matrix. You can find it out. It is possible, but we'll see how. We'll also see that exponential of a matrix. We can find this thing out with the help of diagonalization. We can do it. We can also find that how can we find out the sign of a matrix. But this is at the end. It's very easy. Once you diagonalize the matrix, you can do everything. I am going a bit fast because these are very basic things. The next idea is what we call block matrices. This is something new for us. So let us discuss this thing in detail. So block matrices. So I have a matrix A, I have a matrix B. I am going to define this matrix. This matrix is very long, but I am going to write it in very simple form. So the matrix A is divided in 4 blocks. The first block is identity matrix with 3 rows and 3 columns. You know very well, 1 0 0 0 1 0. And this is also identity. This is a null matrix O3, but it is O 2 3. And this is some matrix C. Now I will define what is C matrix, because you know everything in this one. You know I3, you know O2 3. This is null matrix. You don't know what is C, so I am going to define it. So C matrix is 2 1 minus 1 0 minus 2 and a 3. So you got this C matrix. And what is B matrix? It is again some sort of blocks. Block 1 2 3 4. There are 4 blocks. Hence we call these block matrices. So this is D, and I don't know what is D. I am going to define it. O32 and O32, and this is again D. Now what is D? D is this matrix 1 2 2 1 minus 1 1. Just if I ask you, if you write this A matrix, then can you write this matrix? It will be very long matrix, but we can write it.
So in terms condition का square matrix या कोई भी
No. It should be, I think, some sort of rectangular matrix. I think these are rectangular matrices as well, but we'll see that whether these matrices are rectangular or square. Okay. So the problem is A matrix is very lengthy, B matrix is very lengthy. So we are going to write these matrices in some simplest forms, and it is not possible for every matrix. Because in this matrix, when you make blocks, you exactly get null matrix, you exactly get identity matrices. You can make blocks in every matrix, but those blocks will not help us. These blocks are helping us to find out the product. How do you find this product?
Clockwise.
Clockwise. It's very simple. So what do? You take this row, multiply with column. It means what happens?
Identity with multiplied by D.
Identity multiplied by D plus
I3 multiplied by
I3
432.
432. And then
Yes, I3.
should I not write it explicitly? This will be null.
हाँ सर डायरेक्टली लिखो.
This will be
D.
D.
Okay fine.
This will only be D. And then I multiply this thing with this one. Identity with null, null, identity with D. But you have to see that whether you can do it or not. Can you multiply identity with D? What is D? You can.
Three was
Because in identity there are 3 columns, in D there are 3 rows. You can do. So you can identity with this,
Yeah.
and then identity with D will give you D. Now the second, null with row, column. Null with D, null. C with null, null. This is a null matrix, but it will be 3 by 2 or what? This, what is the order of C? 2 by 3. What is the order of row? Column. This is 3 by 2. So it would be 2 by 2. It would be 2 by 2. Now this row with this column, null with null, null, C with D would be C. So when you multiply AB, you exactly get this answer. Now when you write the whole matrices and you multiply, it will be very lengthy. Now what you do exactly, you have D, put it here. You have null, 0 0 0 0, put it here. You have D, but only thing is you have to find out CD. CD just multiply C with D and you are done. So this is how you do. But the problem is it okay? So only you should satisfy the order. If the orders are okay, then you are okay, otherwise not. So sometimes these block matrices are very much helpful, and it is only possible when you make the blocks in your matrix, but those blocks should be defined in some sort of ordinary matrices. like identity and null, then your multiplication becomes easy. Otherwise, there is no use of these things. So,
गुलाब देखे पांच ठाणे पंद्रह
no. You are given two matrices. You have to identify that can you make these things or not. You have to identify, and if there are very lengthy matrices, then if you can identify the things, that's very good. It is not possible always, as I told already. So, what is the order of D? D would be like these 6 entries. Okay, I am writing in this way. D will be these 6 entries. And D will be 6 entries. 1, 2, 3, 4, 5, 6. Let us do like this. D 6 entries. This D 6 entries. This will be how many entries? 1, 2, 3, 4 entries. And CD, C, D. What's the order of C? 2 by 3. D 3 by 2. So 2 by 2 it means 4 entries. So your multiplication is okay like this. This is just entry wise calculation that whether we are okay or not. Okay, so maybe we will need block matrices and maybe not. So now matrix vector multiplication. So you have some vector B and you are going to multiply it with some vector with some matrix A. So A belongs to, let's say, AMN, and V is a vector in Rn. So the first thing that we should keep in our mind that V is a vector of this form. And we can also write this into some sort of column. This is one thing. So in vector spaces we denote vector in this way. In matrix algebra, whenever I write a column vector, a column matrix, I mean a vector. So this is a vector V. Can I find this thing? Is it possible? What is the order of A? Mn.
Yeah, it's possible.
How many columns? How many rows? How can we do it? How to define it? So the definition is, take the first entry, V1. It means it's a number. It's a number. Multiply with the first column of A. Because A matrix would be having some columns A1, A2 up to. Is that so? Then B2, A2 up to Bn.
BI solution.
Yes, BIA solution. You can write in that form as well. So, what are these? These AIs are the columns of your matrix A, and these V1, V2s are vectors. Now, are components of our vector V. V1 is a component, V2 is a component. So, in other notation, you can write this is V1, and this is a column. It means what are the entries in this column? Let's say A11, A21 up to A M1 plus B2 A what would it be now? 1 2 A 2 2 up to A M2 up to Bn, and then A 1n A2n up to AMN. This is exactly that. Because Yes, it is the same idea.
So A1 is what? There. AB.
These are the components.
A1, A2 are the columns of your matrix A. Because this is a matrix, no? You can say that okay, this is first column. Now this is another way to write your matrix. This A1 is not a number, A1 is a column like this. A2 is a column, A3 is a column, and so on. So these are columns. Okay, now I can relate this thing as well. You solve this system in, I think, in matrix first year or intermediate mathematics. What is this system? There is a matrix A, there is a variable matrix, and there is a constant matrix. Is that so?
Yes.
Now in your variable matrix, if I am considering 3 by 3, there are 3 columns. I am not writing each and every entry. I am saying this is column, this is a column A1, this is a column A2, and this is a column A3. I am saying this thing. Okay. So this is matrix A, this is variable matrix X, this is matrix B. And I have written your matrix A into these columns. Now what I do exactly, if I find the linear combination of these column vectors with X, Y and Z, X, Y and Z would be here, I will exactly get this matrix B1, B2, B3. It means the linear combination of these columns with these coefficients gives you this matrix B1, B2 and B3. Okay, we will be doing this idea later on, that what do we mean by the column space, what is the span of columns, and do those columns generate some sort of space or not. So these things will be related later on, but we are going to build the theory now. Okay, what do we mean by matrix multiplication, the matrix with the vector multiplication. So this is building the theory. Then we will be doing, okay, where can we use these things. Okay, we can write the multiplication of two matrices in this way as well. But this is okay, only up to now we should know how to multiply a matrix with a vector using these columns and coefficients. Now the idea that is a bit important, what we call linear transformation.